Hello everyone. My project is about predicting first attempt delivery failures in cross-border e-commerce logistics. In the logistics industry, one of the most common pain points we face is when a parcel can be delivered on the first try. This creates extra costs, delays, and unhappy customers. In this project, I will show how machine learning can help reduce this problem. The specific problem is failed first delivery attempts, or FADF. Why is this a good ML opportunity? First, the business value is high. If we reduce failures, we save on redelivery costs and improve customer satisfaction. Second, we have rich data, shipment details, addresses, carriers, timestamps, and delivery outcomes. Third, it's feasible. This is a narrow, well-defined binary classification problem. Either the first attempt succeeds or fails. Our objective is to predict the risk of first attempt failure when the shipping label is created so we can take proactive action. Success means fewer failures, shorter delivery times, and fewer customer complaints. We will measure success using both business metrics, such as reduction in failure rate, lower costs, and higher NPS, which is Net Promoter Score, that measures customer satisfaction. And in addition, we'll use a model metrics like AUC above 0.8 and well-calibrated probabilities. Some factors that drive risk include the shipment itself, like weight or fragility, the address quality, such as rural versus urban, the courier and service type, the timing, like around holidays, weather events, and also historical lane performance. My solution concept is to use a gradient-boosted tree model to predict the probability of failure. To validate it, we'll start with offline experiments, training on past data and validating on recent months, looking at metrics like AUC, precision, and calibration. Next, we'll move to online validation. First, in shadow mode for 2 weeks, where the model makes predictions but doesn't affect decisions. Then an A/B test. The control group uses the current process, and the treatment group uses model-guided interventions, such as suggesting pickup lockers, sending SMS reminders, or switching couriers. We'll measure outcomes like reduced failures, fewer complaints, and lower cost per parcel. The system will run in the cloud for scalability, and because shipping decisions are now latency critical at the millisecond level, the model will be trained offline on a weekly basis with daily refreshes for certain features like lane failure rates. Predictions will be made online at the time of label creation, so we can act immediately. The flow is shipment data goes into a feature store. Then the machine learning model produces a risk score, and if risk is high, we can trigger interventions like address confirmation, a locker pickup option, or switching carriers. There are some risks in production. We could see training serving skew if the way we parse addresses offline differs from online. We will fix this with a central feature store. We could have latency issues if we rely on external APIs like weather, so we will cache daily data. We expect data drift, for example during holiday surges, so we will monitor feature distributions and retrain as needed. There's also concept drift. If couriers change policies or new services appear, we'll use challenger models to adapt. Finally, feedback loops are possible. If we always avoid one courier, we lose data. So we'll reserve a small percentage of shipments for exploration. In Conclusion: this project shows how machine learning can reduce first attempt delivery failures in cross-border e-commerce logistics. The benefits are clear: lower cost, faster delivery, and happier customers. The system is feasible, the problem is measurable, and the impact is significant. As a next step, I would pilot on A/B tests during the busy holiday season when failures are most costly. Thank you for listening.